Okay, Algebra 2 students, here's a video for Example 3 and Example 4 for Section 6.2, Understanding Continuously Compounded Interest. Consider an investment of $1 in an account that pays 100% annual interest rate, which is way more than you would ever get. But anyways, pretending it makes the numbers come out easier. The equation would be A equals 1 for the initial dollar, times, in parentheses, 1 plus 1 over n. N is the number of times that you're going to compound it to find the interest, raised to the n times 1. This is very familiar, very similar to the previous example. They want us to find the value in the account for the number of periods given. So if we compound it just once over the year, how much money would we have? If we compounded it 10 times, how much money would we have? 100 times over the year, how much money would we have? All the way up to, what if we compounded it 100,000 times over the course of the year? Okay? And we talked about this a little bit previously, so you may already have an idea of how that will all work. They have it already for if it's compounded once, we would end up with $2. 100% of $1 is $1, so 1 plus 1 is 2. So we'd end up with $2. But if you compounded it more often, and let's see if I move the slider, we will have this compounding. So here it is compounding 6 times during the year. It would come out to $2.52, $2.52. They wanted us to do it for multiples of 10, so let me go up to 10. So at 10, it's at 2.59, and then if we go up to compounding it 100 times during the year, we would have 2.70, $2.70. If we compounded it 1,000 times, we would have $2.72, and I'm just going to go to the end. If we compounded it 10,000 times during the year, it would be 2.71814. I mean, with dollars and cents, it's really $2.72 still. It still rounds, but there is a limit. If you go out enough places, at some point, you get to the end, I guess. Get to the forget how to minimize this. Here we go. Notice that as n continues to increase, the value of the account remains very close to 2.718. This special number is called the natural base. Just like you memorized pi many years ago, 3.14, the natural base e is this 1 plus 1 over x to the x as x approaches infinity. And that number is an irrational number, 2.718281828459. It just keeps going and it never repeats, even though it looks like there was a bunch of 2 8s and 1 8s there. It never repeats. This number is the number e. And it's used, the banks use it for compounding interest. The amount that you have can be found by this formula here, PERT. Whether you have the principal, you have the initial principal, the initial amount of money you put in, or the initial amount, because it doesn't have to be money. There's the continuous rate, R, the interest rate, and T for the value in the account after T years. We're going to apply this A equals P E to the RT in the problems in these two examples. Let's see what we have here. Oh, they're just wondering, if we went to 1,000,000, would the value in the account increase or decrease? How would you know? Well, since every single number has been increasing, the more often we compound it, it would get even larger. It would get even closer to E. Remember E, the 2.71828. I don't have it memorized past there, but let's apply it in the next example. There's no homework on example 3, but it was good to know that before going into example 4. Regina invests $12,600 in an account that earns 3.2% annual interest, compounded continuously. That means we're going to use the PERT formula. What is the value of the account after 12 years? Round your answer to the nearest dollar. All right. So we have the initial amount, P, is $12,600. The rate, it's 3.2%, but then you're going to move the decimal over 2 places, so you have 0.032. T, 12 years, and then we plug it in. 12,600 e to the 0.032, 12. On the previous stuff, we had 1.032, but this isn't asking for the 100. You don't need the 100%. You just need to put in the rate, the annual interest. Okay, see if you can type that into your calculator to get that value, $18,498.63. Oh, they said round to the nearest dollar, didn't they? So that would round up to 18,499. You may want to click pause to make sure you can type that in correctly. If not, I'm not going to do it on this one. I'll do it on the next problem. Sorry. If you invest $125,000 in an account that earns 4.75 annual interest rate, compounded continuously, what's the value in the account after 15 years? What's the value of the account after 30 years? Okay, I'm going to click pause and give it a shot and come on back. I'm going to go right to my calculator and type that in. Even though I forget where the E button is, I may need to put on my glasses to see where the E, oh, there it is. It's down here. Okay, initial amount, $125,000. Times E, which is in blue, so I need to go blue. And it's raised to a certain power. Now the power is supposed to be R times T. R is 0.0475 and T is 15. Holy smokes. Oh yeah, 15 years, that makes sense. $254,885. Now for 30 years, I'm going to use the previous entry function and then just get into this and change it to 30. That looks to be correct. 519,732. Let's see if those two answers show up when I click the answers here. I believe those are the answers I had. Yes and yes. All right. And that's it. So let's see what the assignment is. 20, 21, 29, 31, 32, 27. That's it for this video. Have a great day.